Hello everyone, this is Nirali Patel from New RJ Institute of Engineering and Technology. In today's lecture, we are going to continue with the examples of the binomial distribution. So let's get started. It is given that if 3 of 12 car drivers do not carry driving license, what is the probability that a traffic inspector who randomly checks 3 car drivers will catch one for not carrying the driving license? So over here, it is already given that a traffic inspector who randomly checks 3 car drivers. So from that, we can say the number of trial n is equals to 3. Here we want to find out the probability that traffic inspector will catch one for not carrying the driving license. So that is P of x is equals to 1. That is the number of success is 1. Here the probability of success is do not carrying the driving license. So 3 of 12 car drivers do not carrying the driving license. So P is equals to 3 by 12. That is the 1 by 4. And Q is equals to 1 minus P. That is the 3 by 4. Now P of x is equals to 1 is NC1 P raised to 1 Q raised to n minus 1. The value of n is 3. So 3C1 P raised to 1, that is the 1 by 4 raised to 1 and 3 by 4 raised to 1 and n minus 1, that is 2. So this is equals to 0.4222. Now moving to the next example, it is given that out of 1000 families with 4 children, how many would you expect to have first at least one boy, second 2 boys, third no girls, fourth 1 or 2 girls, given that probability of boy is 0.5. So over here, if you are taking the P is the probability of success, that is the probability of boy. That is 0.5. So Q is the probability of girl and that is equals to 0.5 as well. And in each family there are 4 children, so n is equals to 4. And that there are total 1000 families, so capital N is equals to 1000. Now let's first find out for the first case, that is for the at least one boy. So first case is for the at least one boy. So how many family have at least one boy? So first let's find out the probability for the at least one boy, that is x greater than equals to 1. And that is equals to 1 minus P of x is equals to 0. So 1 minus NC0, P raised to 0, Q raised to 4 minus N minus 0. That is equals to 1 minus 4C0, 0.5 raised to 0 into 0.5 raised to 4. And that is equals to 0.9375. So this is the probability for at least one boy. Now, how many families have at least one boy? So the number of families with at least one boy is equals to 1000 into 0.9375. So that is equals to 937.5 and that is near to 938. Now the next case is for the 2 boys. So second is for the 2 boys. So similarly, first we find out the probability of 2 boys. So NC2, P raised to 2, Q raised to n minus 2. N is equals to 4C2, 0.5 raised to 2 and 0.5 raised to 4 minus 2, that is 2. And that is equals to 0.375. And for 1000 families, or the number of families with 2 boys, is equals to 1000 into 0.375, and that is equals to 375. Now the third case is for the no girl. So we can say that that is equals to 4 boys, because here the P of x is equals to x. So this x denotes the number of success. And here as a success, we take the boy, because the probability of success is the probability of boy. So that's why your whatever the x, that must be denote the number of boys. So that's why P of no girl is the probability of no girl is the probability of 4 boys. So P of x is equals to 4 is NC4 P raised to 4 Q raised to n minus 4. So 4C4 0.5 raised to 4 into 0.5 raised to 4 minus 4, that is the 0. And that is equals to 0.063. So the number of families with no girl is equals to 1000 into 0.063, and that is equals to 63. The next is 1 or 2 girls. So fourth is 1 or 2 girls. So we can write that is nothing but the 3 or 2 boys. So P of x is equals to 2 plus P of x is equals to 3. So 4C2 0.5 is to 2 into 0.5 is to 2 plus 4C3 into 0.5 is to 3 into 0.5 is to 1, and that is equals to 0.625. So number of families with 1 or 2 girls is equals to 1000 into 0.625, and that is equals to 625. Now moving to the next example. So the following data are number of marks out of 5 for 50 students. So capital N is equals to 50, N is equals to 5. Fit the binomial distribution to the following data. So here the number of successes and the frequency is given. So this is the number of success with the actual frequency. As we have discussed in the binomial frequency distribution, the binomial frequency distribution is nothing but the number of successes together with that expected frequency. So here we have to find out the expected frequency for all possible successes. So the all possible successes is nothing but 0, 1, 2, 3, 4, 5. And for this number of successes, we have to find the respective expected frequency. The formula for the expected frequency is n into P of x is equals to x. So let's first find out the f of 0. So that is the n into P of x is equals to 0. N is equals to 50. P of x is equals to x, that is the NCx P raised to x Q raised to n minus x. But x is equals to 0, so 50 into NC0 P raised to 0 Q raised to n minus 0. Now here we have the value of small n, that is the 5. So over here we require the value of P and Q as well, because we have already the value of n, that is the 5, but we don't have the value of P and Q. So in order to find the value of P and Q, we require the mean. And the formula for mean is equals to sigma fx upon sigma x. So we can find the mean from this x and f. So let's find out the mean first. So let's find out the mean. So the value of x is 0, 1, 2, 3, 4, and 5. F is 27, 14, 6, 3, 0, 0. So sigma f is equals to 50. Then f into x, so that is the 0, 14, 12, 9, 0, and 0. So sigma fx is equals to 35. And mean is equals to 35 by 50. We know that in the binomial distribution, mean is equals to NP, that is equals to 35 by 50. N is equals to 5. So P into 5 is 35 by 50. So P is equals to 7 by 50, that is equals to 0.14. So we can say that Q is equals to 1 minus P, that is 0.86. Now we have the value of N, P, and Q, so we can find the f of 0. So f of 0 is equals to 50 into and C is 0, 0.40 raised to 0, and 0.86 raised to 4, 5, as n is equals to 5. So f of 0 is near to 24. Similarly, we can find the f of 1, that is n into p of x is equals to 1. So 50 into 5c1, 0.40 raised to 1, 0.86 raised to 4, and that is near to 90. Similarly, f of 2, that is n into p of x is equals to 2, that is equals to 50 into 5c2, 0.14 raised to 2, 0.86 raised to 3, and that is near to 6. F of 3 is equals to 50 into 5c3, 0.14 raised to 3, 0.86 raised to 2, and that is near to 1. F of 4 is equals to 50 into 5c4, 0.14 raised to 4, 0.86 raised to 1, and that is near to 0. F of 5 is equals to 15 into 5c5, 0.14 raised to 5, and 0.86 raised to 0. So that is also near to 0. Here the whatever the expected frequency that we have to convert into the integer number from the floating point. So you have to round about some integer number to get the final answer. So the binomial distribution is given by x and f of x. The value of x is 0, 1, 2, 3, 4, 5, 24, 19, 6, 1, 0, 0. So this is the binomial distribution for the given data. So this is all about today's lecture. In next lecture, we are starting with the Poisson distribution. Thank you.